Hi, welcome. Today we are going to start the first chapter of thermodynamics. Let us start with the definition of state function. The function which depends on the initial and final state of a system is called as state function. For example, temperature, pressure, volume, enthalpy, internal energy, etc. All these are the state functions. So it means that all these functions depends on the initial state and final state of a system, and they are independent of the path followed. So all these are the state functions. Second definition is path function. The function which depends on the path followed between two states is called as path function. Again, very simple definition. This is the function which depends on the path followed between two states is called as path function. For example, two are the most famous examples are there: work done and the heat involved during a process, W and Q. These two are the path functions. So these state function and path function two are the basic definitions before we have to start the next points of the thermodynamics. Now next point is, which is important, exact differential. Now suppose if a system is taken along a path, for example by heating it, its internal energy U changes from U1 to U2. See, suppose if we have a system whose internal energy initially is U1, and if we heat that system, there is a change in internal energy takes place and its internal energy becomes U2. Okay, the overall change in internal energy, which is denoted by delta U, is equal to integration of du from U1 to U2. So we can write delta U is equal to U2 minus U1. What we can write? Delta U is equal to U2 minus U1. So the difference delta U is equal to final internal energy minus the initial internal energy. Okay, so we can say that the value of delta U depends on initial and final state of a system and independent of the path between them. So that change in internal energy does not depend on the path followed, but depend only on the initial state and the final state. Okay, so this path independence, here I highlighted these two words, path independence. There is a no dependence on path. This function is path independent. So this path independence of the integral is expressed by saying that du is an exact differential. I repeat, this path independence of the integral is expressed by saying that du, that is change in internal energy, is an exact differential. Okay, now in general, what we can say, what is an exact differential? An exact differential is an infinitesimal quantity that when integrated gives a result that is independent of the path between the initial and final states. So this is about the exact differential. An exact differential is an infinitesimal quantity that when integrated gives a result that is independent of the path between the initial and final states. Okay, so when we say exact differential, it is path independent. Okay, so this is about the exact differential. In next lecture, we will study what is an inexact differential. Thank you.